Here's a question from 2018. It says the diagram shows part of the curve y equals 2, 3x minus 1 to the power of negative a third, and the lines x equals 2/3 and x equals 3. I'll show a picture of it on the screen now. The curve and the line x equals 2/3 intersect at the point A. We'll need that later on. This is the first part of the question, and it says, find, showing all necessary working, the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. And it's worth 5 marks. This is a big question. When you're rotating a region about the x-axis, then you're doing something called the volume of revolution. There's a formula for working it out. It's using integration, and it's given by this. Pi times by the integral from the lower limit to the upper limit of y squared dx. I'll try to include an animation on the screen now that illustrates what's going on. When you rotate the curve about the x-axis, you make a circle. The area of the circle will be given by pi times the radius squared, and the radius is given by the height of the curve, which is just y. So going back to this formula, we have pi times the radius squared, so it's pi times y squared. And then integration is just a fancy way of adding up all those little areas, and if you add them all up, you get the volume. So this is the formula you need to know to work out the volume when you rotate something about the x-axis. So let's do this. Okay, so I've got the formula here. We're given what y was, that was this. And so substituting it in, I also have the lower limit of x equals 2/3 to an upper limit of x equals 3. So let's go ahead and expand this with the power 2. So 2 squared gives me 4. And I have something to the power of negative a third all to the power of 2. Well, when you have a power to a power, you need to multiply the powers. So it'll give me negative 2/3. And now I need to do this integration. And that means I need to do anti-differentiation. Okay, so 4 times some problem. If I anti-differentiate, I get 4 times the answer. And when I have a power, then I need to add 1 to the power and divide by the new power. So if I add 1 to negative 2/3, I get positive 1/3, and I divide by that new power, positive 1/3. And this extra factor of 3 here is because it wasn't just simply x to the power of something, it was 3x to the power of something. And so the chain rule says I also need to divide by the coefficient of x there. Now 1/3 of 3 is just 1, and so the denominator is just 1, and so we can ignore it. And so we have this expression here, wrapped up in square brackets, and the limits, which were x equals 2/3 going up to x equals 3, I've written over here on the right hand side. Now to work this out, I need to substitute in the upper limit first. So substitute in x equals 3 into this expression and work it out. And then also substitute in x equals 2/3, the lower limit, into here and work it out and find the difference. So let's do that. When we substitute in x equals 3, you get 3 times 3, which is 9, minus 1. That gives you 8. 8 to the power of 1/3 is like doing the cube root of 8, and the cube root of 8 is 2. And then 2 times 4 gives you 8. So there's the expression evaluated with x equals 3. And when I put in the lower limit, I'm going to get 3 lots of 2/3, which is going to give me 2. 2 minus 1 is 1. The cube root of 1 is 1. 1 times 4 is 4, and so there's my 4. So that was the expression evaluated with the upper limit. That's the expression evaluated with the lower limit, and I find the difference. Now 8 to take away 4 is 4, and this whole problem had a factor of pi, so I'm going to have 4 pi as my final answer, which is approximately 12.6. That was only the first part of a 2-part problem, and this is the second part, also worth 5 marks. It says find the equation of the normal to the curve at A, giving your answer in the form y equals mx plus c. I'll try to include an animation here, but this involves finding the value of the gradient of the tangent at the point A, and then from that finding the gradient of the normal at the point A. And then when we have the gradient of the normal and also the coordinates of the point A, we can just use the standard formula which gives you a straight line. So you need to know what m is, the gradient, and the coordinates of the point A, which will be x1 and y1. So we know that at A, x is equal to 2/3. It's where the curve and the line x equals 2/3 intersect. So that's my x value, my x1. And if I substitute that into the expression for the curve, that'll give me the value for y. So putting in x equals 2/3 in here gives me the value y equals 2. So we know that the coordinates of the point A are 2/3 and 2, and that's our x1 and our y1. Now to find the gradient of the normal, first we need to find the gradient of the tangent at the point A, and that's done using differentiation. Here's the expression for the curve, and we need to differentiate this. So 2 times the problem will give us 2 times the answer. Bringing the power down the front, we're going to have minus a third here. We're going to have this expression, and then I need to take 1 away from the power. Well, if it was already negative a third, and I take a further 1 whole away, then I get down to negative 4/3. Now, it wasn't just simply x to the power of something, it was 3x to the power of something. And so the chain rule says I also need to multiply by a factor of 3. This can be simplified a little bit. 1/3 times by 3 just gives us 1 whole. So we have negative 2, and then this expression to the power of minus 4/3. That gives you the gradient at any value of x, but we'd like to know what the gradient is at x equals 2/3. So when x equals 2/3, dy by dx is equal to minus 2. And that's the value of the gradient of the tangent. The gradient of the normal is negative 1 divided by that. So the relationship between the normal and the tangent is that one is negative 1 divided by the other. So the gradient of the normal is going to be negative 1 divided by negative 2, which is positive a half. So recall that the point A was given by 2/3 and 2, and we know that the gradient of the normal is 1/2. So that means that the equation of the normal is y minus the y value, which is 2, equals a half, brackets x minus the x value, which was 2/3. Now we need to expand this out and rearrange it to make y the subject, and that's pretty easy. You get the final answer there, which is y equals a half x plus 5/3. And that's the end of the question. Here's a question from 2019. It says the diagram, and I'll show it again, shows part of the curve y equals x minus 1 to the power of minus 2 plus 2, and the lines x equals 1 and x equals 3. It says the point A on the curve has coordinates 2, 3. The normal to the curve at A crosses the line x equals 1 at B. And here's the first part of the question. It says, show that the normal AB has equation y equals a half x plus 2, and it's worth 3 marks. This is very similar to the previous question we just did. So let's find first the derivative. And the derivative is going to be given by bringing the power down the front, negative 2, brackets x minus 1 to the power of, and then taking 1 away from the power, negative 3. And the constant 2 there just disappears. So that's a pretty simple derivative. We want to know its value at x equals 2, because that's the point that we're interested in. So at x equals 2, the gradient of the tangent is minus 2. So just substituting an x equals 2 in here, we find out that the derivative gives you a value of minus 2, and that will give you the value of the gradient of the tangent. The gradient of the normal is just going to be negative 1 divided by this, and again that equals positive a half. And I think we have all the ingredients we need now to work out the equation of the normal AB. We have the gradient of the normal, and we have a point on the normal, which is 2, 3. That would be like your x1 and your y1. So the equation of the normal is going to be given by y minus the y value equals the gradient x minus the x value. And if you expand this out and rearrange a little bit, you sure enough do get what you're after, which is y equals a half x plus 2 for 3 marks. This next question is worth 8 marks. It's a monster of a problem. It says, find, showing all necessary working, the volume of revolution obtained when the shaded region is rotated through 360 degrees about the x-axis. It's very similar to the problem we did previously. I'll try to include an animation on the screen right now, but basically you have a straight line segment and a curved segment, and when we rotate it around, that makes it a natural idea to break it up into 2 volumes. Okay, so we have the volume of the straight line segment going from x equals 1 to 2, and then the curved segment from x equals 2 to 3. Don't forget that we're using the volume of revolution formula, so really it's pi times the y value squared, which is just like thinking about pi times the radius squared, and that's the area of the circle, and then the integration means we're adding up a whole bunch of little circles to give us a volume. And then for the curved part, we have the y value coming from here. Okay, so that's going to be its radius squared times by pi, and we're integrating between x equals 2 and x equals 3. What we need to do is we have something squared, so we need to expand it out using FOIL. So 2 brackets of this, and we'd have a half x times another half x, giving you a quarter x squared. And then you'd have a half x times by 2 and another half x times by 2 to give us 2x. And then finally, the L in FOIL, the last terms, 2 times 2 gives you 4. So expanding out the 2 brackets that the square represents, I get this expression. And likewise over here, if you expand it out using FOIL, you get this expression. So now let's do these integrations. So let's just focus on this first one first. And so a quarter x squared, if I add 1 to the power, it becomes to the power of 3, and I need to divide this expression by 3. Well, a quarter divided by 3 is a 12th, x to the power of 3. So I've added 1 to the power and divided by the new power. 2x would become x to the power of 2 divided by 2, and the 2's would cancel, leaving us with x squared. And 4 becomes 4x. And the limits of integration are from x equals 1 to x equals 2, and I put them over on the right hand side of these square brackets. Over here, the second one is somewhat similar. I need to add 1 to the power, and if you add 1 to negative 4, you get negative 3. Divide by that new power, negative 3. Couldn't find a nice way to write that, so I'm just going to leave it like this. And then 4 times this problem, so 4 times its answer, and adding 1 to the power, negative 2 plus 1 gives you negative 1, and I divide by that new power. And 4 again goes to 4x when anti-differentiating. And the limits from x equals 2 to x equals 3 are over here on the right hand side. So now I need to substitute in the upper limit. So x equals 2 inside here, here, and here, and work out what it is. And substitute in the lower limit, x equals 1, here, here, and here, and work out what that is. Find the difference, just like we did before, and then multiply it by pi. And I'm going to do that all over again over here with the upper limits x equals 3 and the lower limits x equals 2. If you work through all this, you get an exact answer of 111 over 8, and everything was times by pi. So 111 over 8 times by pi, which if you work it out numerically, is approximately 43.6. And that was worth 8 marks.